On the whiteboard. For 5D, you could factorize out the negative sign, alright? So if you were to do that, then it would be a plus, alright? So usually either one of it is fine. Okay, but like I said, usually they will not ask you to just differentiate a certain expression. Okay, but it's just a matter of I think people usually just don't like to have so many negative signs on the numerator, so they usually like to have the negative sign factorized out. Okay, so it's just a matter of habits. Alright, any questions regarding this? Yep. Sorry? This one? Brought the 5, expand inside, not an issue. Yeah, it's equivalent. Okay, anything else? Yeah.
Sine S is like cosine T.
Why? Keep this, differentiate this, right?
So I think like the answer.
The final line,
Yeah, right, okay.
the minus 3 sin x is asking if you can times the minus 3 sin x times in.
Times in, since you do that.
But it's 3x.
If you draw a graph,
Yeah.
what does this mean? This means amplitude, right? This is period, right? Can you times it in? Then amplitude different, right? Never? No. Okay. Anything else that you would like to clarify? Right? If not, let's move on. Okay. So we have covered and looked at how chain rule can apply for trigo functions. I will look at how power rules can apply. Okay. By the way, before I go into power rules, right? Okay. Take note that in this case, sine 3x bracket square is equivalent to sine square bracket 3x. Okay. So they are actually the same. So meaning to say that at this point you should be aware that notations wise sine, cosine, tangent, if I put bracket square, okay, it is the same as having the square inside. They are the same thing. Okay, however, this does not apply for power of negative 1. Okay, the power of negative 1 in this case, this is equals to 1 over sine x. It is not equals to sine inverse x. Right, so at this point I hope that we are all clear about how this trigo functions actually work. Okay, so the power negative 1, okay, in this case it's a power, but in this case it is an inverse. Right? So inverse, meaning to say this will find you an angle. Okay? So looking at how power rules will apply, okay, this will actually be very important, right? So let's look at try 4.
So then negative 2
Negative 2,
with 1 over sine square.
yeah, so in this case, if I were to have sine x to the power negative 2, this is equals to 1 over sine square x now. Okay, but we usually do not write things like that. Yeah, we never come across of sine to the power negative 2x. Okay, no. Okay, so looking at try 4, if I have cosine cube x, okay, so if I want to differentiate this, understanding our power rule, so we will bring down the power usually, right? Then after that, we will minus 1 to the power, so become cosine square x. Then after that, don't forget we need to differentiate cosine itself, okay? And that will be negative sine x. Okay? The reason why this is the case, it is because, okay, cosine cube x, we acknowledge that it is the same as cosine x to the power of 3. Alright? So when we do things like, for example, differentiating x cubed, we will get 3x squared, right? Okay? Then after, if I want to say, for example, differentiate maybe x plus 1 cubed, there will be 3x plus 1 squared, then we differentiate the inside. So okay, maybe put 2x. Differentiate inside, that will give you 2, correct? So understanding this, okay, if I want to differentiate cosine x bracket cube, hang on, okay, we bring down the power minus 1, differentiate the inside, which is cosine x, that will give you negative sine x. Right? So that is how the power rule is consistent throughout all the different kind of functions. Yes, your question? Okay, so that's why we will be getting this. Okay, so then after we simplify this, negative 3 sine x cosine square x. Okay?
So in any power, cosine x, cosine 1 power x will always be negative sine of x.
Cosine x,
Cosine to the power of whatever is equals to negative sine x. That's always.
cosine x itself differentiated, it will become negative sine x. The power itself is due to power rule. So it's the cosine x itself that will be differentiated to become negative sine x.
Cosine you differentiate cosine cube x. It actually becomes negative sine x. So cosine anything that power to anything x is actually equal to negative sine x.
No, it's not equal to negative sine x. There's still this and this part, right? Yeah lah. But understand that you should be getting is because differentiate cosine x itself will give you negative sine x. Yeah, it's not about the power. The power itself is about how power rule is being applied. Yeah. You understand? Okay. And so part B, okay, we want to look at differentiating tangent x minus 3 to the power of 4. So if this were to be equals to y, so dy over dx, bring down power, then the same expression, power minus 1, differentiate the inside, that will give you secant square x. Okay? So simplify this for secant square x. Tangent x minus 3 to the power of 3. One last question for the day, part C. differentiate square root of 1 minus sine bracket x plus pi. So we would see that this is the same as 1 minus sine x plus pi to the power of half. Okay, and we let this be y. So dy over dx. Okay, then after differentiating the inside, so 1 differentiate will be 0. Then negative sine x plus pi, so therefore it will become negative cosine, okay, x plus pi. Sorry, I write it below. Okay, and then since x itself is x only, so differentiating the x plus pi, that will only give you 1. Right? So then simplifying this, negative half sine x plus pi, and then after that 1 minus sine, or rather put it in fraction. Okay, sorry, this one. Okay, so you can express this into a fraction because this power of negative half, so it becomes in the denominator. Since this is half, right, so the 2 is in the denominator. Okay. Any questions? Okay, if no questions, I'll call it a day over here. Alright, tomorrow we will continue with this. Okay.